The chain rule. In this video, we will learn how to differentiate composite functions. If you don't remember what composite functions are, watch this video that appears in the upper right corner before proceeding. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. So far, we know how to differentiate simple functions. Simple is a subjective concept, and it may be best to illustrate what it means. Examples. The following functions are considered simple. We have seen the techniques for differentiating these basic functions, as well as sums, differences, products, quotients, and constant multiples of these functions. Let's begin discussion by differentiating the first function g of x. This function is simple, and its derivative can be found directly from the power rule. Let's try to differentiate the function f of x. How would we differentiate an expression like this? Our first thought might be to use the power rule on this we would get. But is this so? To check this, we expand the function f of x. We now take the derivative of this function. This is the correct derivative of this function. So the power rule alone simply will not work to get the derivative here. The power rule is valid for any power n, but not for any base other than the simple input value x. Therefore, the power rule or any other differentiation formulas we learned in the previous videos do not enable us to calculate this function. But we know how to differentiate both g of x and h of x. So it would be useful to have a rule that tells us how to find the derivative of f in terms of the derivatives of g and h. Observe that the function f is built up of the two simpler functions g of x and h of x. Technically speaking, the function f is the composition of g and h. It turns out that the derivative of the composite function f of x is the product of the derivatives of g and h. This fact is one of the most important of the differentiation rules and is called the chain rule. The chain rule. If the function f is differentiable at g of x and the function g of x is differentiable at x, then the derivative of the composite function f of g of x is given by. In the composition f of gx, we call f the outside function and g the inside function. With this terminology, the rule says that the derivative of the composition of two functions is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. The chain rule may also be expressed using Leibniz notation. If u is a function of x and y is a function of u, the derivative of y with respect to x is the derivative of f with respect to u, the derivative of u with respect to x. The chain rule expresses the derivative of a composite function in terms of the derivatives of its components. Now let's go back and use the chain rule on the function that we used at the beginning of this video. Find the derivative of the function f using the chain rule. We use the chain rule here because we have got a composite function. That's one function, 2 times x plus 1 inside another function, the square function. In using the chain rule, we work from the outside to the inside. So we begin by viewing f of x as a composition of functions and identifying the outside function in the inside function. The inside function we denoted by u, and u equals 2 times x plus 1. The outside function we denoted by y, and y equals u squared. We differentiate f with respect to u and differentiate u with respect to x. These results can then be substituted into the chain rule to give the desired result, dy dx. So the derivative of f of x with respect to x is 8 times x plus 4. We now prove the chain rule. If f of x and g of x are both differentiable functions and we define y equals f of g of x, then the derivative of y with respect to x is. Look at the graph. For a small change of x, there is a small change in u and a small change in y as well. Below, we show how to derive the rule. We multiply by delta u and divide by delta u. By the graph, we see that as delta x tends to 0, delta u tends to 0 as well. So we can substitute limit as delta x tends to 0 by delta u tends to 0. What we need to do here is use the definition of the derivative and evaluate the following limits. From the definition of the derivative, it follows that this proves the chain rule. Let's see other examples. Find the derivative of the function using the chain rule. The outside function is the square root, and the inside function is the stuff that we are taking the square root of. We now set u as the inside function and f of u as the outside function. Then we apply the chain rule. We calculate df du and du df. Finally, the derivatives can be substituted into the chain rule to get the answer. Now we will combine the chain rule with the other rules we have learned. Find the derivative of the function using the chain rule. For this problem, the first thing that we will need to do is apply the product rule. We calculate the derivatives. The second derivative is very simple, but in the first derivative, we must apply the chain rule. At this point, we have calculated the derivative. If we want to rewrite the derivative in its simplest factored form, we should go on. Writing the derivative in the factored form would require a significant number of additional steps. Although there are some instances that require us to write the derivatives in factored form, we will consider the additional steps optional at this point. Find the derivative of the function. Unlike the previous problem, the first step for the derivative is to use the chain rule. To apply the chain rule, we identify the inside function and the outside function. We differentiate f with respect to u and differentiate u with respect to x. To find the derivative of the outside function, we apply the power rule. To find the derivative of the inside function, we apply the quotient rule. Pay attention. Finally, the derivatives can be substituted into the chain rule to get the answer. After a lot of algebraic work, we can write the derivative in the factored form. You should try to solve the next example yourself and then check the answer.